here's the thing that nobody's talking about. We have these incredible, powerful AI models like GPT-4, Claude, all latest tech. They are still breaking in production. Research from 2024 shows that knowledge representation is still one of the biggest headaches in building AI systems that actually works. It is literally the bottleneck that we are currently living in. So we have powerful models like GPT-4 here, repeated again, and we're trying to reach general understanding of things. The bottleneck is here, the ability to represent information or to represent knowledge. Even with all our fancy neural network, we are stuck with the same problem. How do we get machines to actually understand what they know? Look, the models themselves are fine. They are smart, they are fast, they are trended on half of the internet. But here's what actually happening. They are failing because how knowledge is organized. So if you have LLM with hundreds of billions of parameters, you are just dumping messy data to your LLM, which is not structured, with no rules or with no predefined relationships. So only messy files, unrelated, with no links. So what actually is happening, they are failing because of how knowledge is organized or really not organized inside them. It is like having a brilliant employee who can't find anything in a messy failing system. The intelligence is there, but the structure to use it, that's what is missing. Now let's talk about hallucination. OpenAI's own research from 2025 shows that their training method actually reward AI for guessing instead of saying I don't know. And it was pretty rare to find an LLM saying I know when you ask a question. Think about that for a second. We are literally training these systems to PS their way through answers. Still hallucinate in over 30%. I think in over 30% of cases on basic benchmarks. Anthropic found that Claude will hallucinate when it recognizes a name, doesn't have enough real information about that person. The model isn't broken, it just don't know how to respond versus what it is guessing. So literally, if you are using GPT-5, you are getting 70% correct answer versus 30% hallucination, which is pretty ridiculous. And we're talking about the latest model from OpenAI and based on their own research. Okay, story time. A New York attorney used the ChatGPT for legal research. Out of 115 cases, citation 47 were completely fake cases, made up fake cases, fake law, real and real courtroom, when knowledge is just broken and random, unstructured, in just chunks or wherever they are using to embed knowledge in vector databases or whatever. So these aren't edge cases. This is what happens when knowledge representation fails. So everyone think if you dump enough PDFs into a system, you've given it knowledge. And that's wrong. Text is just raw data. It is unstructured. It is disconnected. Just text. You can embed the text, but you can't have like rule-based relationships between different entities inside your text. So it is basically a pile of information with no organization. Standard RAG systems, that's retrieval augmented generation, just chop documents into chunks. So if you have like many documents, you're gonna split these documents into smaller chunks, and then based on your question, you're gonna use one of these chunks to retrieve information from. That's the whole concept of retrieval augmented generation, which is, I think, is pretty ridiculous for complex use cases like legal or medical domains. And that's why we are seeing AI fails in different industries. People just think that embedding knowledge is enough, or embedding text to be able to have like an expert AI in a specific domain. But this is not true. So here's what is missing: the connection between facts. So literally, you need to have something like this. It is very simple, abstracted way to represent knowledge. Entity relationship. This is a global method to represent knowledge, and it is very scalable. It is literally unlimited, and we often call it knowledge graph. So the connection between facts, that's what gives information meaning. I'm going to talk more about this part specifically, including the different components that they are involved in representing knowledge. So just to conclude one fact, these random chunks doesn't means that you have knowledge, and doesn't means that you are representing the knowledge in a way that you can use for complex use cases as you might think. Now, vector embedding is cool. You can embed text in multi dimensions, so you can use like similarity check and different mathematical ways to retrieve knowledge or to answer questions, etc. So vector embeddings are cool, don't get me wrong. They can be used for sentiment analysis, for any kind of similarity check. Similarity isn't the same as understanding. So embedding can tell you about cause and effect. They can't handle time. They can't reason about rules. Just because your AI remembers your last conversation doesn't mean it has memory in any meaningful sense. Conversation logs are flat. There is no structure for reasoning over time. No way to learn from patterns. No ability to say, hey, this approach worked last time. Let's do it again. You can't ask what pattern lead to this outcome. So in the same way, chat history is just a flat chat history with no links, with no pattern detection. So you can't learn. So you cannot retrain your model to learn pattern or to avoid doing any kind of bad practices, because again, you need to represent the memory or the chat history into something linked or into rule-based representation, because there is no system to track casually. It is just a transcript, not understanding. So what knowledge actually needs? If text, the chat history aren't enough, what do we actually need? Real knowledge representation requires 5 things. The first thing is entity, and the entity is the things in your domain. Treatments, wherever you're working with. And the second thing that you need, and the second component is relationship, or R, which is the link between an entity and the other entities. So relationship, not just these words appears together, but actual connection. The third component is rule, and it is the logic. If this and this, then that. It represents hard constraints like patient under 18 can't get this treatment. So you can represent this as the following. We have the E and the R right here, and still we have a rule, and we have a rule setting here to define the ability of building this connection based on constraints, and on the other side we have another entity. The fourth component is context, and it is very, very important. Context. Context let your system answer things like, when does this apply? Is this law still valid? Does this guideline only work for certain cases? So it is the overall or the general context that is going to be used to handle complex links between different and like millions of entities. So we can represent the whole thing in the following figure. We have entity, which is E, and it is linked with relationship to be linked with another entity, and this relationship has rule or set of rules, and the rule is linked to context and causality, C and C. The final figure can be visualized like this. Let me give you a clean definition. Knowledge representation is how information is structured in a machine that can reason, not just retrieve. And that's the key destination. Retrieval is easy. Google does it. Vector databases do it. But reasoning, that requires structure. So we need to differentiate between two major things: retrieve and reason. So here you can just retrieve from a document just to answer a question, but on this side you need to have a structure with the 5 main components that we've talked about. So you can apply reasoning on structured data. Now here's the uncomfortable truth. We are really good at scaling the easy stuff. Model parameters. We went from to trillions training data. The hardest stuff representing actual meaning and relationships, including how experts actually think, maintaining logical consistency across millions of facts, handling information that contradicts itself. That stuff doesn't scale at all, and that's your bottleneck. So we have things that we can scale like parameters, data, and compute. But other things like meaning, relationship, logic, these are the things that is hard to scale, unlike those parts or components, parameter, data, and compute.